SQL query statements. Now previously we were looking at the idea of just how SQL works with Java, and now we're going to go a bit more in depth in the actual language itself for SQL, how we can actually use it. And so SQL has a couple different statement types. The statement types are the ways of actually looking at the language, of how the actual language works, and what we do to actually do some stuff with that. And I've split this up into 3 different categories. 2 of them are official, and 1 is just a little supplementary one that I'm using there today. The first one is DDL. This is the data definition language. And the data definition language is used to actually put together and create the actual databases. It's actually not used for taking care of the data itself, but rather the structure behind the language. And the DML is the manipulation language. It's the data stuff that you actually put into the database, how you take things in, put things out, or change the values. So we use that for a variety of things. And that last category, the other category, are add-ons to existing statements. It's a way of doing more with the statement than simply what it has by default, but rather adding detail to it. The first statement we want to look at is the select statement. It is a DML statement. And select chooses information from the database based on user-supplied information. The structure is select, and then you put the fields that you want separated by commas, and you can put them in parentheses if you'd like. The keyword from, again, in SQL, we keep all of our keywords with all caps because it is not case sensitive. And then the corresponding tables. And all statements in SQL end with a semicolon. You can combine your select statement with a where and or an order by clause. And the select statement will return a table or a result set. So what this means is that select, basically, when you call the select on a database, on a set of tables, it gives you its own little mini table. It doesn't save that mini table unless you tell it to. But it's a particular way of actually taking data out of all the tables and making your own temporary table from that. In Java, we will refer to that as a result set. And we'll use that quite often. So we have a field example right here. Select age from my table. And here's my table. As you can see, we have an ID, a name, age, school, and car fields with values in all of those. 3 different sets of records. And so we are going to select the age field from that table, which brings us the values of 43, 84, and 18. So all it took is simply that one part of the table and returns it to us as a little mini table. So this is doing just simply one field from the entire table. As I said, this can be combined even further. This is how you do it with a where clause. Select everything from my table where car is not equal to none. So I'm going to look at my table, and I want to get everything that's not where car is not equal to none. That is, excuse me, where car is not equal to none. And so I get, in this case, a table of 2 rows. I get Sergio and Sarah out of my table, because they do not have car equal to none. They have new or used. The next statement we want to look at is the delete statement. It is often we have to actually take data out of a database. And so we use the delete statement to do that. The structure is delete from table or tables where some check. And it will return the number of deleted rows. If you do not put a where clause in there, it will delete everything. And that would probably suck. So we have a delete sample right here. Delete from my table where ID equals 3. We're going to delete from my table where ID is 3. Now I have Sarah and Ted. So I take off the entire row. Delete affects the entire row of the database. It doesn't just take out that field. Delete is the way of affecting an entire row. Now all these statements we're using right here are just regular SQL statements. If we went into phpMyAdmin and typed them into the SQL box, that same thing would happen. We could also use these statements inside our Java program, provided I substitute, instead of a backtick, I put an apostrophe. So the insert statement is a DML statement as well. Again, it is manipulating the data. What is it kind of manipulation? It's inserting data into the table. And so it adds information to the database, as I said. And so the structure on this is you have the keyword insert, followed by the fields that you want to insert into. You separate each of those fields by comma. You may use a parens around it, but it is not required. I find it much nicer to keep the parens around the fields. It makes it look a little bit cleaner, a little bit more structured code. Then the into keyword, and then table, which table you're putting it into. Then the keyword values, and then values separated by commas so they match the exact same order as you had the fields. You can put them in any order you want in this first section, where the fields separated by commas. However, that same order must be replicated in the values section. In a database, the order of the stuff does not matter. As long as the information matches from the insert to the values section, you can put it in any order you want. If a field is auto-incremented or allows a null value to be placed into it, you don't have to put it in when you call the insert statement. That is only the case if you are using an auto-incremented field or a field that allows null. In our class examples, all our fields have required a value, but our auto-incremented fields can be skipped because they automatically will be generated by the SQL database engine. And so if you don't care about what number your auto-increment field is, you do not have to place it here in the field section of the actual insert statement. This is especially helpful on the Java side. Lastly, we're going to return either n or 0 based on success or failure for each successfully inserted row. If you insert 3 rows, it would return 3. If you inserted 1 row, it would return 1. If the insert statement is not successful, it will return a 0. And as you guys saw, if we insert things incorrectly, we get lots of SQL errors. So we have a correct opportunity, and if it does not insert properly, it would return a 0. A quick little sample. Insert into my table, name, car, school, age, values of DERF none SUU 8. If you notice, I am not inserting an ID value. Because the ID value is not being inserted, we can assume that it is either A, null is acceptable, or B, auto-incremented. As it is the ID variable, we should most likely assume that it is B, auto-incrementing. Further note that name, car, school, age is not the way we see it on the actual database. But as long as we actually put the values in right here, DERF, that fits a name, school, matches a school, car, matches a car value, and age matches an age value, we are going to be a successful insert. And as you can see, it does not actually affect the database in the order you put them in, because it will just still keep them in that same built-in structure. And as you note, the ID is auto-incremented. 566 is the next number after 565, and so DERF has that as his ID. His 8 as an age matching that last field, even though it is the third field in the database. So the insert itself, the order of the fields does not matter, as long as you put in the fields that require a non-null value. The update statement we haven't looked at yet. Update is used to change data in the database. It's a way of actually manipulating, say for example, an existing order. And we combine it with the set keyword to assign field values. If you do not want to change everything in your database, then you need to make sure that you have a where clause, or everything is going to be updated. And that would be a bit of a problem. It'd be like everything being deleted, except possibly even worse, because then all data in the table would be updated with whatever value you just had inserted. The structure on that is update, table name, set, field name equals value for each field, separated of course by commas, where field name equals some value. The where clause is how you specify which one you want to update. Update my table. Set ID 799 where car equals new. So we are going to change where car equals new. We're going to change its ID value. Sergio is the only one with a new car. If Ted had a new car, we would also be affecting Ted's ID to be 799. And that would be a problem because we have to have unique things for a primary key. As you can see, Sergio now has 799 as his ID, and Ted is still 565, Sarah is still 54. The update or the set does not change other fields that we have not specified. And again, if we had not put that where car equals new, everyone in there would have an ID of 799, which would cause a SQL error because SQL does not like having duplicate copies of primary keys. And that would be bad. The DDL statements are the next section we're looking at. We're not going to go quite as in depth on these because these are separate and we've talked about these in other ways. Our DDL statements are drop, alter, and create. Drop is how we delete a table or a database or simply take an index or field out of that table. If we want to have something no longer be the primary key, we can drop the primary key. Or we can drop the entire field itself from the table. Alter is how we change a structure after it's been created. And this is always used for the creation of foreign keys. We saw that when we looked at our SQL statements earlier, when we saw the actual SQL statements when we were printing them out from the export statement. The alter statement happens after the table has been created, and we use it specifically when we're changing the structure of the table. Create obviously makes something, and we use this with the keywords table or database. Our other statements that we have, the first one is order by. A database does not care about the order of the contents inside it. In a database, order has no meaning. Hence the fact we had those IDs that went 5, 3, 4, 799. That didn't matter. The order of it doesn't matter to the database. Rather, the order matters to the users of that data. And we can make order happen by using the order by keyword, even though it's 2 words. It doesn't actually alter that content, it simply just changes the way it's presented. We use the order by with the select statement. And by default, ascending order is what happens. So A, B, C, D. We'll use alphabetic order by default, or 1, 2, 3, 4, 5. Numeric increasing order. However, we can also change it to be descending. The structure is listed below, where we have order by passing the field name or names, because we can have multiple order bys, and then ascending, ASC, or descending, DESC. Select everything from the table, order by name field, and have it descend. So that will take the entire table and have it go backwards by name field. So Z, Y, X, V, W, down to A. The where clause is used to do specific parts of things. This is how you identify things in SQL. It's used to limit data in the database. It is not its own thing, but rather, like English, it is a clause, something you put into a other part of the statement. The where clause uses relational operators that we've used already. Greater than, less than, equal to, not equal to. It can also use another keyword known as like, which is similar to equals, but not quite. You can have multiple where clauses. And as I said, it does not exist on its own. It is just like English clause. It's not a full sentence or statement. It requires the rest of the statement to be in there. Where field equals value, or if you're doing multiple things to select, where field 1 equals value, where field 2, or comma, field 2 equals other value. And so that is the basic structure of a where clause. It can be as simple or as complex as you like. If you don't use it on a delete or update statement, again, that delete or update statement will affect everything, which is generally considered to be bad.